Okay, this tutorial is about K-means. So let's go to tutorials, programs, unsupervised data mining. And here we have two programs about K-means. We're going to take a look at the first one. So double click the first program and you get this five operators uh, and that's the program for K-means. Uh, what they do is this first operator reads a data set named iris. The second operator normalizes the data. And the third operator is the K-means operator. This is the operator that's going to find groups of observations that are close to each other. Here we have to make a decision. How many groups do we want to find? So we can try 2, 3, 4, 5. This operator lets you visualize the results of the clustering process. And this one creates a copy of the data set so you can see the data set with a new variable called cluster, which is the result of the clustering process. So let me run the program with two clusters. I run it, and this is what I get. I get the data set with a new variable that is a categorical variable that indicates the cluster, the different clusters that the program has found. What else do I get? I get an output about the results of the model. So I have two clusters. Cluster 0. This is computer science, right? They start counting from 0. So cluster 0, it has 50 observations. Cluster 1 has 100 observations. There's a heat map here that I find it very useful. I find the centroid chart very useful. Two clusters, the blue cluster, the cluster 0, and the cluster 1, the red one. And here we have a relative comparison of the means of the variables per cluster. So in this case, the variable sepal length has a smaller mean for the blue cluster for cluster 0 and a higher mean for cluster 1. So that's the opposite happens for sepal width, high mean for cluster 0 and small mean for the red cluster. So you can compare in what variable the clusters are different. Okay, so let me go back to the program. What if I wanted 3 clusters instead of 2? I just change K. Okay, and then I run again, and then now I get 3 clusters. Okay, cluster 0, cluster 1, cluster 2, and they're more balanced, right? They have about 50 observations each cluster. Now if I want to compare the centroids, I have 3 sets of means to compare per variable. Okay, so that's basically it, right? Now, like I mean, in class we're going to experiment with 2, 3, 4, 5 clusters, and we're going to stop when we have found something convenient. We're not going to use a statistical measure to decide how many clusters do we want to have. It's going to be a matter of convenience in this class. Okay, that's basically how I use a program. But now I want to show you how I modify an existing program like this one to apply it to a new data set. So the programs in these tutorials come with a data set. Sometimes it's a famous data set like this one. This is the iris data set that Ronald Fisher uses in his famous books. But suppose I want to apply it to a data set that I care about. Okay, so I want to show you how you modify an existing program to adapt it to your data set. Okay, so let me erase everything, And let me read the data set that is available in the page of the course. Is here in the blog about clustering with K-means. So this one, breast cancer data set, is a benchmark data set in data mining. So go ahead and download it. If you're curious about the variables in this data set, click on the description of the variables. I already downloaded the data set, so I'm gonna read it into my repository, my classes repository. So I'm gonna import data, desktop, and here's breast cancer CSV. Okay, next. So everything looks fine. Next, okay, we have an ID variable, so we better define that ID as an ID. And we have a label. Okay, I'm gonna use this data set to illustrate K-means, but this data set is gonna be used again when we talk about classification, because what we want to know is, can we classify a tissue, I guess, as having breast cancer or not. So the diagnosis is going to be malignant and benign. Two possibilities actually here. I have polynomial. Let me fix that too. It's binomial. And this one is going to be the label. Okay, so that's going to be the label. But since we're going to use this data set to illustrate K-means, this variable label is going to be ignored. So we're going to use the other 30 variables to build our clusters. So next, and save it in the repository classes. And there it is. Okay, so now I have the data set read into the repository. Let me close everything here. And now I want to show you how you modify an existing program to adapt it to your data set. Okay, programs, K-means, again, double click. Again, it is applied to the iris data set, but now I want to change that. Okay, I want to apply it to the breast cancer data set. So what I do is I basically erase that operator, delete, and I drag breast cancer, and I connect it, and now I have a program to do K-means for this new data set. If you want to save the program, you don't want to press here save, because then it's going to replace the program in the tutorials. What you're going to do is save as, and then you go to classes, and then you say K-means apply to breast cancer data set. Okay, and now you have a program for this new data set, so we can play with it, right? Here's the main operator in this program is the clustering operator, the K-means operator, and here we have two clusters. So I can go ahead and run it, and it's gonna find two clusters, cluster 0 and cluster 1. Let's take a look at some of the stats about this. Cluster 0, 189 observations. Cluster 1, 380 observations. Okay. How about the characteristics of the profile of these clusters? And you see, cluster 1 has smaller means for pretty much all of the variables. For this 2, they're almost the same, but for all of them, for the other variables, the red cluster, cluster number 1, is always below the blue cluster. That's really unusual. And now let me do something else. Now let me export the results of this clustering exercise to Excel, so I can continue processing the data set, or I can do whatever I want with the Excel data set. Okay, so what can I do? Well, that's the second tutorial. Tutorial K-means exporting data. But let me modify this first tutorial so I can show you that sometimes there's a small modification of the data set of a program results in the things we want to do. Okay, so in this case, I want to run the clusters. I want to find the clusters, I mean, and then I want to export them to Excel. So the operator to export to Excel is write Excel. Write Excel. So you put it in, you put it here. See, the wire gets highlighted. That means that if I drop it, it's gonna be properly connected. Uh, Let me repeat that. I drag the operator. If it's highlighted, it gets connected automatically. If it's not highlighted like that, you have to connect it yourself. Okay? Okay, so in this case, we have the same tutorial as before, but now we want to export the data set. Okay, and the only parameter of this operator is what name do you want to give to this data set, and I'm gonna name it clusters out XLSX. Okay, and I run it again, and it's gonna show me exactly the same stuff as before. But in my desktop, I should have in spreadsheets, I should have cluster out XLS. Okay, so I have all the variables, and then I have the new variable cluster. That's the variable that I care about. So let me go to Tableau, and let me connect to that spreadsheet. There it is, cluster out, open. Okay, I have all the variables, and here's the new variable cluster. Let's see how many records do we have for each of the two clusters. Show me bars, and yeah, we have. Remember, we had 380 observations classified as cluster 1 and 189 classified as cluster 0. What I want to do now is I want to show you the graph that I said is available in Tableau, but it's not available in RapidMiner. So I want to see for each cluster what percentage of observations are diagnosed as malignant and benign. Okay, so I can take diagnosis and put it here in color, and you see the cluster 0. Most of the observations in cluster 0 are classified as malignant. And here I want to make it comparable. I want to know what percentage, instead of how many observations. I want to see what percentage of observations are classified as malignant and what percentage is classified as benign. So what I do is I go to analysis, percentage of, column in this case, and now it is perfectly comparable, right? 92% of the observations in cluster 0 are malign, and only 9%, 9.74% are malignant for cluster 1. So I want you to understand this. I didn't use the variable diagnosis to build the clusters. But when I found two clusters, they were very different in terms of size. And when I examined, when I cross the variable cluster with the diagnosis, I realized that the clusters that I found are sensible clusters. Cluster 0 is the cluster that is composed by most of the observations that are classified as malignant. Okay, I'm gonna use this graph many times during the course when we get to classification. Okay, let me stop the video right there.